Okay, so welcome everyone. The usual bi-weekly experience team meeting for smart contracts. Our leader, G-Man, had some personal things to attend to, so I'll be doing the announcement of my own presentation, I guess. So I'll just dive right in. The things happening in the last few weeks. I think 2 weeks ago we mentioned that there was still an open invitation to help with the Rust client side, and I have been refactoring the Rust client code a bit so that that is ready or more ready for it. I still have to define the interface solidly, so there's not something that I can hand over just yet. But we're making small steps of progress there. Personally, I had quite a lot of distractions of little things that didn't work or needed small changes, or some changes in the WASP code that bubbled through into the WASM lib code, so on my end, and therefore I needed to attend to those. So that has pretty much been dealt with, and I'm about to go back to the client-side code. We have found that there's one difference in the way that the Hornet nodes work compared to the GoShimmer node. That was actually something we depend on, which is the transactions. In the GoShimmer node, we have all the transaction information. In the Hornet node, we only have the UTXO information, and we lose the transaction information. And that means that we lose some information that certain classes of smart contracts will need. So I guess once we're at the point where we have the basic system running, we're going to be defining some extra parts that we will need to get that back in. But we first want to have a basic system running, so it won't be the system as we envision it completely yet, but at least it will run and it can be tested, and it can do enough to keep you guys busy. As I said during the banter when we started, we had an important milestone today, which is that we merged the Stardust VM branch into develop. So the develop branch is now based on the Stardust code and no longer on the GoShimmer code. If you still need the GoShimmer version, then you will need to use the master branch that is still based on GoShimmer. But all development will from now on be Stardust, and well, we as a team are no longer looking back to GoShimmer. So there will be no improvements in the GoShimmer versions anymore. Let's see. Yeah, for the rest, the last 2 weeks have been mostly spent with cleaning up stuff, getting tests to run. Oh, that's another milestone we reached today. That is that all our old tests are now running again. So we can now actually run tests on the full WASP repository. So that's a good thing. Let's see, what else do we have? Yeah, some progress on the distributed key generation and the signing with a different kind of signature than the BLS signature, one based on ED, what is it, ED 52911. I never remember that number. But the basic address algorithm that we're using will be used to generate BLS type signatures. So, and it's supposedly going to be faster. So that's good. Yeah, and we're actually getting to a point where when the team member is dropping the thing that he is without task, that our leader Dave is going to threaten them with writing documentation. So that's also a good thing. So we should start seeing documentation show up in the next weeks. So that's going to be very helpful. And that is pretty much it.
And the dashboard login is also not basic anymore, right? It's
Oh
JLDT
yeah,
based.
I believe so. But that's something that flies a bit over my head. That kind of stuff. So I may miss some stuff here and there when I do my reporting, because like I said, I don't have my tentacles in everything. I try to keep up a bit, but I may miss stuff. But last 2 weeks were mostly rounding off loose ends, fixing bugs. We just found that we had a bug where files weren't closed properly, so we were running out of file handles, and that has been solved, and things like that. And when Yang Hao was creating some tests to test the WASM-lib implementation of the data types against the WASP implementation of the data types, he actually found a bug in the WASP implementation. So yeah, things like increasing the amount of tests is always a good thing, right? So you find edge cases that you didn't know existed, and that makes everything more stable. So that's where we're at right now, and that will continue in the next weeks. And as less and less is found and the stability improves, more and more people will have to start documenting. So yeah, poor us. One of the lesser fun tasks of the developers, right? Everybody hates that. Oh well, it needs to be done, and it's also something that's needed if you want stuff that you build to be used by other people. So there's a matter of pride in there, I think.
So
If anybody has any questions or such.
I have a couple of questions. I think those things might also get cleared out a bit. So when you say now we'll be reading from Hornet, the NodeCon is no longer how we're connecting, right? We're connecting via some API address of the Hornet node, is it?
Actually, to be honest, I don't know. That's something that other team members used.
Yes.
I I think that maybe if you look at the WASP cluster code, that you can see how they fire up a cluster. But I have no idea. In that regard, I'm a user, and I leave the magic to the people who have the relevant knowledge about that. And I myself am, I have my specialties, and I leave other stuff to people who have their specialties. So
Of
in
course.
that regard, if I need to run a cluster, I use WASP cluster, and if there's newer ways, or if there's a test net, I wouldn't be able to tell you right now. And once that is there supposedly will be some documentation. People will be able to tell you, but that won't be me.
Right. Of course. And so apart from the connection part with L1, the rest of the things are pretty much the same, I imagine.
Yeah, I don't quite know whether we still have the what's it called, MTTQ of MTQ, or The
MQTT.
The one that you use to listen to messages.
Yeah.
I think we're still using the same one. The Hornet team would like us to switch to their plugin architecture for that.
Uh-huh.
But because we still have enough to do, we decided to delay that until everything is running, and then that will be one of the new tasks after the stuff goes live. Will be to refactor that and well, if depends on the decisions made on that, because it could be that it's not just Hornet we connect to, and therefore we have a different kind of interface, and we might wrap their plugin interface into our own interface so that we can talk to multiple nodes, like for example the B node, or I don't know what will be necessary in the future. The decisions for that are not going to be made by me anyway. So,
Right.
but there was discussion this morning in the team, and I voiced my opinion that it would be better to wait with that until we first have a working version, instead of doing another disruptive refactoring at this point. We're literally so close to having everything stable that it would be silly to upset the apple cart again.
Right. Yeah. Anybody else has some questions for Eric? If not, I have lots of questions, but I would think if somebody has questions, please feel free to ask it.
Eric,
go ahead. Yeah, I have a question later, but I think yours are more valid, better questions. So go ahead.
I was just asking quickly, best place to look for feature parity between WASM and EVM. Trying to just keep my finger on the pulse of that, but it seems like they're both moving targets. So any insights?
EVM is still a moving target in that regard. Diego is working hard on that. The easiest thing to look at is he created a contract, a built-in contract for EVM that is actually the interface to the WASP sandbox, the ISC sandbox. So you can see in that contract which functionality is supported by EVM and which isn't yet or cannot be supported by EVM. The WASM implementation pretty much supports everything in the sandbox, and if there's stuff missing, we will just add it, because we can be as flexible as the sandbox itself. So I haven't looked at how far we are out of sync with the sandbox at the moment, because the WASM team is still only 2 people, so we have had our hands full in that regard. But adding those functions is usually just a matter of adding the function itself and then linking it up to the sandbox code. So that's usually a pretty simple operation. So that's easy for us to stay up to date with the sandbox. So WASM will support everything that the ISC sandbox provides. A lot of functionality that the sandbox used to provide has been moved to core contracts. So, and they can be called by everyone, right? So that reduced the sandbox interface a bit, and it increased the amount of functionality that the core contracts provide. So anything that gets added to the core contracts on the WASM side only has to be added as a definition in the YAML interface file, and then we automatically generate the code to interface to the core contracts. And so that is a very easy fix for us. The sandbox changes are slightly more involved, but even then, I can usually do that in an hour or so. Look at the changes and implement them, and then in all 3 languages and such. It's 4 places where I need to change things then, or add things, and then it's up and running again with the latest. So that's how far we're on par, I guess. Exactly which functionalities aren't available, in the EVM sandbox, I don't know. Like I said, that's Diego's department, and I don't have a clear view on that because I'm not really focused on the EVM. It's all hearsay. Does that answer your question?
Yeah, that's insightful. Appreciate it.
Okie doke. Anyone else?
Alex was asking some questions.
Yeah.
So my question was, when you said initially that not all the node software implementations have the same data, is there actually a valid scenario where you want to have differences, or wouldn't it by default that all node software has to support the same data?
So you need to look at it this way. When Go Shimmer was created, it was basing everything on transactions. Hornet has been focusing on keeping all the UTXOs alive, and so when things are pruned, transactions are the first thing to go, and the only thing that they keep are the unspent UTXOs, the unspent outputs, right? And that's all nice and dandy, but to us, from the smart contract viewpoint, we don't have a pull model, but a push model. So we cannot go out and fetch data from the Tangle because that kind of code is not deterministic. So what we need, contracts are running in a fully deterministic way, but that's only because they don't do any external stuff other than sandbox stuff, which is guaranteed to be deterministic. So any data that you need processing for a smart contract needs to be present at the moment of invocation of a smart contract. So that would be the function parameters of the function that is being called. But one thing that slipped through the cracks, you might say, is the fact that the entire transaction is a context that is static input for the function. So by analyzing the transaction, you can extract certain information because the transaction is an atomic unit. So everything belongs together. And when you start storing the separate UTXOs in the transaction separately and no longer have that link, you can no longer prove that some of those UTXOs were together in a transaction. And that was actually input that we needed, which, well, it's in a big project, such communication mishaps happen. We had that information in the Go Shimmer node, so we never really thought about it until we figured out that they had already optimized away the transactions in Hornet. And then Evaldos was like, oh, wait a minute, but we need that. And then we started patching that with some special outputs on the UTXO side. But the thing is, the transaction is such a generic way of doing it that is so simple that you have all kinds of classes of functionality that you can do with it. And if you lose the connection between that, then for each class of functionality, you will have to come up with a solution to add to the UTXO database. And every solution you come up with comes with its own problem, because you need to write the code, debug the code, analyze it for attack vectors, etc., etc. Things we didn't have before, right? So, for example, the most important functionality in this is the fact that from the viewpoint of the smart contract function call, it can witness certain things happening. So, for example, if you want a smart contract that logs events about things that happen, whether certain transfers occur, you would create a smart contract that the function call is nothing more than register this, and then the smart contract could analyze the transactions that have been made that have nothing to do with the smart contract and register those in its state. So you have proven that you did those transactions, and it's trustless because it's an atomic unit that is completely sealed and cannot be tampered with. So once that data is in the state, the transaction data can go. We no longer need it. But until we have actually registered that data, so process the function and register that data, it needs to be there. Otherwise, we cannot witness those UTXOs. So it could be that those UTXOs have already been executed in the database, and then since we don't know that they are part of a single transaction, we cannot witness them, and therefore we cannot register them. And the registering contract could be used to prove that they were made. So you could have functions in the contract that you can use. Did this ever happen? Right? And then the contract will give you that happening. So that kind of information is no longer available to us. So we need some add-on words, but we are currently defining what way would be best to do it. And I believe that Evaldos already came up with 3 different ways of doing it. So we're now analyzing which one would be the best, and we're waiting with the implementation of that until after the release.
Yeah, it's good. Yeah. What I just actually, when you talk about this, wondered, I'm sure you guys are thinking about it. You know, there's a lot of commonality with how IOTA smart contracts work, with how smart contracts work in general, but there are some unique aspects of it, right?
Yeah,
So
this is
having
one.
a paper that points out these unique aspects, so that somebody can, on the one hand, quickly get their hands dirty and embrace it because they understand the way it works, but also understand how it works differently, that provides caveats or new opportunities, would be a great thing to have, right?
Yeah. One of the interesting things is that you can witness requests going to multiple chains. Once they're in the same transaction, you know from one smart contract on one chain that another smart contract on another chain actually got a certain information. Because both smart contracts that are in that transaction, both requests are in the same transaction. So each of the chains, each of the smart contracts has the exact same data to analyze. So they can see from each other that they both have been invoked. And that's
that means
kind of a behavior.
I could actually, it's very cool. And if I actually have a transaction that has certain input that represent this atomic data set, then I could actually have in parallel 2 different smart contracts that compute two different things. One could calculate blah, and the other calculates blah. Yeah.
Yeah, or one
Things that are,
calculates and the other does the historical data storage, for example.
or one, let's say, deals with operational aspects of this transaction, the other one with financial aspects of this transaction.
Yeah,
But they
I
do that
mean,
in parallel based on the same input.
if you need
Provably.
a lot of storage for both, right, for the historical data and for the calculations and such, then it could be a good thing to split that over two different nodes, where one node does the calculation and keeps track of the data in its state, and the other is only registering whatever it was that happened in the past. And since they are taken from the exact same atomic context, they can be linked without any problem. Right, and even running on different chains. So yeah, that kind of behavior is it opens up whole new possibilities, and that's
So it's almost like a tree, right? So I have one atomic set of a transaction, yeah, and that can branch out into different smart contracts, different dApps, computing on top of that atomic
but
set.
it's like
It's
it's
not
a
really
way
tree,
of synchronizing separate chains, essentially.
Yeah.
Right.
Pointing to the same
Normally,
root,
separate chains run in parallel and do not influence each other. But sometimes you need some trusted synchronization between them, and the transaction mechanism was an ideal candidate for that. Right, because they both know that they got the request. They don't know for sure that it has been executed, but they do know that the requests were there. So if you used optimistic processing in that regard, you can pretty much assume that the other side will have executed that, and that you can guarantee that the other smart contract will, for example, keep the history for you.
Yeah, that's interesting. I don't know if the other guys knew that already, but yeah, I want to defer to other questions.
There are a few more examples. I would have to look it up. Ivalis wrote a document in which he made a very good case on why this is actually an essential, fundamental part of the ISC, and why we need it back, or at least a mechanism that gives us the links, right? So we're looking at a way that can still be optimized away easily, but as long as it's needed, stays around. And in most cases, we don't need anything staying around because there is no witnessing happening. So we're looking at a way to indicate for a transaction that it contains witnessing data, and therefore isn't allowed to be thrown away unless all the outputs are spent, right? And otherwise, it needs to keep those links somewhere, and that the way that is being set up is currently being discussed. So, in addition, I would like to add, I may get a knock on the door because I am expecting a plumber to fix a leak. And he was going to arrive at around 9:30, which is already the case. So it might be that I suddenly need to run. So
Is it a memory leak?
no, this is actually a water leak. No, otherwise I would do the plumbing myself. Actually, I could do this plumbing myself as well, but since I'm renting this place, I'm not going to bother. If it was my own house, it would have been fixed already. So any more questions?
So, I mean, obviously, this is a huge change from the point of the development side. For the end, like for the application developers, how big of a change will it be to switch to this new setup? Will they need to change a lot of things? say if they are just using the testnet endpoints or anything as such?
I think those will all change because the old ones are all pointing to GoShimmer networks. So
Right. So, but
again, that's not my expertise area, so I'm not quite able to tell you that. The thing I do is I simply fire up a WASP cluster and then I'm up and running
right.
for my testing and such. If there's going to be a testnet that stays up, right? Because WASP cluster obviously only stays up as long as you keep it up, and then you lose everything that was there. So there is going to be a testnet, but I'm not quite sure which one.
Right.
That ding-a-ling-a-ling you just heard indicates. Oh,
So,
the plumber is running late. He will be there at 11ish. Okay, so that's easy.
lucky.
Sometimes
So,
delays
we
are a
won't
good
be
thing.
interrupted. That's good. That works out
Sometimes
well.
delays are a good thing.
Yeah. Oh, I expected them to be late. I've never found a plumber or an electrician or a handyman to be on time. No, we're too busy. So, any more questions?
Anybody have some questions? Please go ahead.
I know, like of course, I'm always interested in understanding. So things are moving in the right direction. It sounds like it. Yeah.
Yeah, we're really close to the finish line. From what I understand, the Hornet team is even closer to the finish line. So there will be a Shimmer net without ISC before there will be one with ISC. So that's good, I guess. So people can already test some stuff. But yeah, the smart contracts are of course the icing on the cake, right? I mean, I'm of the opinion that without smart contracts, IOTA may as well go home.
Absolutely.
Yeah, I mean, if we don't have smart contracts, what are we doing? It's literally the fact that we are able to cross connect different chains trustlessly. That is one of the biggest selling points, and to be able to do it for free, of course. So yeah, it's going to be interesting to see whether we're going to become the backbone. But we first need everything running for that.
For sure, for sure. Any other questions anybody has? I have a lot of questions, but just want to see.
You don't want to monopolize.
Yeah,
Don't hold
exactly.
back. No, you're right. I think every question is good. It's entertaining everybody else, and there's always something new we learn. So shoot.
Yeah.
All
I will
right.
make up answers anyway.
I mean, there's obviously a lot of things happening, especially with the Shimmer Extremes testing going on. So there's a lot of exciting things that I have a lot of questions about. So the first thing is now we can obviously mint N on L1 native tokens. How will that differ from the smart contract as from the smart contract based tokens, and why should somebody use a smart contract based token versus L1 native token?
So the native tokens can move seamlessly between chains, right? We're going to have parallel chains, and those tokens are simply in your wallet. You know how you have those ERC20 wallets with multiple tokens, right? that often also has an exchange functionality, but it uses a centralized exchange to so that you can exchange token X for token Y, right? But they're all Ethereum based, and you need Ethereum gas for most of the tokens to be able to swap them, things like that, right? The IOTA wallet is going to be a wallet like that, where the native tokens that run on the IOTA chain or the IOTA Tangle can freely be sent to anyone. And so you have trustless ownership transfer. You have an unlimited amount of tokens. It's not that thing where if the wallet doesn't support a token, too bad. No, any token will be supported. So if I create a token, then I can start sending it around to other people, and they will be able to receive it.
Which is the Firefly, right?
Yeah, that's a Firefly thing, and we don't have any influence or ability from the smart contract side to track that.
Right.
We don't have to. And then you have the point where you touch the smart contracts. So those tokens are sent to a smart contract chain, and they will be received in the address of that chain. The chain has a central address that keeps track of all the tokens, or all the tokens on level 1, on the Tangle level, are stored. And the chain also keeps an administration of that. It keeps track of who sent it to them, and it assigns those tokens into its own administration to an account for that sender.
Right. So this is L1 to L2 that's happening right now.
Yeah, it's not exactly wrapping, because this is still the way that the level 1 and level 2 interaction functions together. So they are the same tokens. It's like all the tokens that are being sent from different users are sent to the same pool, but the pool keeps track of which tokens are sent by whom, and therefore who owns them.
Exactly. So
Right?
this is a major difference between what in general in the crypto's ecosystem, L1 to L2 transfer happens.
Yeah. So at the level 2, then in those accounts is being kept track of the tokens that are on that chain, right? There are actual, you could say, physical tokens backing them up in the address of the chain. And the account is a virtual accounting on top of that to keep track of it, to make sense of it. It's somewhat like the way an exchange works, right? If I send my tokens to an exchange, then they go to some address of the exchange, and I don't care about that, because the exchange will create an account for me in which it keeps track of my tokens, and I can always retrieve them from there. This is exactly the way it works in the chain accounts. Nobody can touch your tokens, not even the smart contract, without your permission.
Perfect.
Right? So you can use your private key of the address, because the address that sent the tokens is the sender as far as the chain is concerned. So it will store those tokens under an account for that address. And if you can prove ownership by signing with your private key, then you can withdraw them again to your own address without any troubles. The highest thing you pay is some gas fee, or maybe if the chain has fees, then you might pay a little fee for that. But otherwise, there's no overhead involved, and you can essentially send your tokens around. And then at the level 2, when you do a call to a smart contract function, when you do a request to a smart contract, you provide an allowance to that smart contract. So where previously you would send the tokens along with the request, you can still do that, but the tokens don't end up in the smart contract like before. Instead, they end up in your account, and you provide an allowance of the tokens that the smart contract for that request is allowed to use. This means that if you make a mistake and send tokens to a smart contract that doesn't know what to do with it, in the previous situation, the tokens would be in the smart contract address, in the smart contract account, with no way to retrieve them. They would be lost. In the current situation, the tokens end up in your account, and if the smart contract doesn't know what to do with the allowance, it simply will do nothing, and therefore the tokens will still be in your account. So only if the smart contract knows what to do with the tokens that you provide, will it actually do a transfer to its own account. And
Right.
that means that there's a lot of safety built in. Your tokens, even when they are on the chain, are yours and yours alone, and cannot be touched by anyone else. That's
Now,
the difference with the exchange analogy. The
Right.
exchange could rug pull you and run off with all the tokens. That's not possible in the smart contract scenario. So in the chain scenario, the chain can never run off with your tokens.
exactly. And also when you say that the node which is holding the accounts, that is not just the only node. The entire committee will sort of sync up, right? So the account will exist.
This is a committee thing, right?
Right.
The state is always kept track of by the entire committee, and state changes, transfers are part of the state changes. They will only be accepted when the minimum amount of people agrees with them.
Right.
Right. So there's your rug pull scenario. If 2/3 plus 1 are malicious, they can still rug pull you, but that's a scenario that you will find everywhere essentially.
Of course.
And it's probably better than most cases, because I believe in most cases 1/3 or 1 or half or so is necessary to rug pull. So we're even better than that with our 2/3.
Definitely.
So anyway, about the wrapping. So now assume you have an ERC20 contract, right?
Right.
ERC20 doesn't create tokens on chain, or on the tangle.
Right.
An ERC20 contract keeps track of all the tokens it has and who owns them. So that's actually, you could say a level 3 accounting that's happening.
So
because the level 2 accounting on the chain will actually keep track of all the tokens that are owned by everyone, including the smart contracts. And the smart contract itself will then do accounting on the tokens that it owns with respect to who owns the tokens of that, right? That's what an ERC contract usually does. And the only way for such a smart contract to keep track of them is as long as they are in the smart contract. So now you have kind of an impedance mismatch, because you will want to transfer tokens between chains, and even those ERC tokens would be nice to be able to be transferred.
Exactly.
So what you can do is you can create a corresponding level 1 token, and the supply of that token is controlled by the smart contract. So it controls a foundry. The foundry will create the tokens out of thin air when necessary, and will destroy tokens when necessary. So you create a supply, and those are being sent to an address. Or initially they are in the smart contract accounting, the level 3 accounting, you could say. And then the moment you want to transfer them out to the Tangle, what you will do is you will increase through the foundry the supply of the wrapped token, the token that wraps the RSC token. And then you can send those new tokens to the corresponding entity that wants them on the Tangle, right? Once they are sent, they exist only as the level 1 tokens anymore, and there is no accounting for them anymore on the smart contract. So for the smart contract, they don't exist. The smart contract only governs the ones that are in the smart contract itself.
Right.
So once you transfer them out, you wrap them as a level 1 token, then they can be sent around. And anyone who wants to use those tokens will probably have to send them to the smart contract first to do something with them, because the smart contract knows what to do with them.
Mhm.
So then those wrapped tokens, once they are sent to the smart contract, they end up in the address of the chain, are being passed as an allowance to the smart contract, and then the smart contract takes them up, looks who sent it to me, increases the account with the proper amount of number, or the proper amount of tokens, and if they want, they can actually decrease the amount of level 1 tokens, because they are now part of the chain of the smart contract anyway. So the foundry can reduce that amount, and they don't need to be kept around because they are now in the accounting system of the smart contract. So that's how you do wrapping, right? You either have it accounted in the smart contract, or you have them exist as wrap tokens on level 1, where they can be freely passed around.
Right. And now, if somebody wants to create, let's say, a token registry, that will be in several levels, right? Like one is the native tokens level. Then there'll be based on the smart contracts level, right? So there'll be different stages of that. Will the foundry take care of, say, mapping of these as well, or will that need to be done?
No, the foundry is very simple, essentially. The foundry only defines a limit to the amount of tokens, the current amount, and the current minimum amount. You can set an upper limit and a lower limit, and you have the actual amount. The one who controls the foundry, whether that is a smart contract or a normal user or whoever, decides whether they will mint tokens out of thin air, and then they can be sent to a level 1 address. So the foundry doesn't know anything about those tokens once they are being sent out. It's just the foundry is nothing more than those 3 values, essentially: the minimum amount and the maximum amount, so that the Tangle can make sure that those boundaries aren't breached, and the amount currently in circulation. So you can mint them, and then they get added to the amount in circulation, but you can never mint more than the upper limit. And you can, what we call, melt them. So the foundry can actually destroy tokens from circulation, and then the amount circulating becomes less, but it can never go below the lowest number, which is usually 0.
Right.
Then there's a third option, that is that tokens are destroyed. So that means they are not sent to the foundry, but they are sent to, for example, the 0 address, which nobody has the keys of, and then there is simply nobody, and those tokens will be lost forever. So those are the 3 scenarios: minting, melting, and destroying tokens. And who does that? The only one that can mint and melt is the foundry owner, and anybody can destroy tokens if they don't want them anymore.
Awesome. Any more questions from anybody else here?
And by the way, this goes for NFTs as well, right? An NFT
Right,
is just another token.
Yeah,
they can be minted out of thin air, and they can be interesting. For example, I mean the current way NFTs are being used with those stupid images or videos and such is beyond silly as far as I'm concerned, right? And most people laugh about the whole thing, but they don't realize that there are actual use cases that you could have. For example, one that Ivaldas described in his document, where we were talking about witnessing stuff. You could, for example, have a smart contract that is a name server, a DNS kind of system. The system could witness a transaction on an address, which is simple, a transfer of one token to its own address as part of the transaction. So the contract would not even receive a token, but it only witnesses the transfer, and therefore it knows that this address owns the tokens, and it's the same address that does the request. So now the request could be a request to register this name blah blah, or Eric, or something like that, right? Then the smart contract looks, is this name already taken? If not, then it mints an NFT for that name, sets the metadata of that NFT to that name, and then sends the NFT to that address. Now we have a registration of a name associated with an address. Right? And this NFT is actually useful, because now if you want to prove ownership of this name, all you need to do is take the NFT, transfer it to the same address where it's at, and then you are proving that you are the owner of that NFT and therefore of the associated name.
Yeah.
So that's a very interesting case, right? And in both cases, all we need to do is witness the transfer, and the token itself never leaves ownership of the original owner. And yet the owner can decide to transfer, or if I have registered Apple, I can decide to sell it to Apple. Apple decides to buy it from me for $1 million, right? Sends me $1 million, and I will send the NFT to their wallet. Now they own it, and they can prove their ownership. So now they own the name. So that's really interesting behavior, and you can also use a lot of this to disconnect names from people. There's a whole lot of use cases that goes way beyond what I can explain in this session, but yeah, NFTs are actually useful, and I found there was a presentation a while ago. Wasn't that a Zignar presentation? Where they were talking about NFTs and how they used it, and I was like, that's the first time I actually saw NFTs being used in a sensible way and made a case for why they are actually a thing. Most people only look at the stupid monkey images or whatever, or robots, and I'm like, what the fuck?
You made the utility part of it. I think somebody from here, Zignar, is here, if they can just do it. Or not. No problem.
So anything else?
Yeah, sorry. We're using NFTs to incentivize gamers by doing annotations or image annotations. So
Right, that was the one. Yeah.
Yeah. Mm-hmm. Yeah. Still, well, we had an alpha test of the image annotation integration with smart contracts using Wasm VM, and indeed, thanks to the coordination that we had with Eric, one of the key differences with EVM is that we can process string types through WASM VM, whereas for EVM, you can only process integers or number types. For an front-end integration directly with a WASM VM, that has lots of possibilities. For our use case, it's specific to send the JSON messages or to send the parameters of the image annotations. And there is also the NFT side of things, apart from the annotation, that is purely the integration with smart contracts or IOTA WASM VM, in where the gamers get rewarded on their activity or for their attention with NFTs that they bought on, and with transactions that are completed through the NFT marketplace. So yeah, we're working on the NFT marketplace side of things more right now because it's what it's creating a revenue stream. But there is already some good progress with the game itself. So once we have both to a decent level, then we can start the integration.
Cool, really cool. Oh, by the way, there's another interesting use case for the witnessing, and that is voting. Right now, we have the DAO vote going on, right? But it's not exactly trustless. There's a central part to it, and it's very specific to the specific vote. With smart contracts, what you could do is you could have your voting tokens and you can lock them for a specific period. You can create an output that says, I am sending them to myself, so therefore I prove that I own them. But the transfer will only take place at time X. And so what you would do for voting is the voting deadline would be taken as the time X, and then you do a transfer to yourself, but with a delay. So all the time that those tokens are out there, you cannot do anything with them. You cannot undo it or whatever. They are simply locked until that time. And the contract can witness that. It knows for sure in a trusted way that those tokens are voting a certain way. And then after the vote is counted, after that time limit, then the tokens are released back to the users and they can be used for yet another vote in the future. But since it's the smart contract that is doing the witnessing and the smart contract is doing everything trustlessly, there's no third party that can actually interfere with the voting. So that's another way the witnessing is important, and it's kind of a different class of usage.
Yeah, absolutely. And for obvious reasons, right now we couldn't wait till the smart contracts was there to do the voting on that, but soon we'll do all of the voting via smart contract itself.
Yep.
All right, I think we are on time, and but if any last questions are there, please go ahead. Or really thank Eric for his time and everybody else. And we can start wrapping up. Any last questions? Or discussion topics, something you want to share? New experiences?
Okay. I guess that wraps it up then.
Yeah, that wraps it up.
Thank you guys for attending, and thank you for listening to me rattling on and making up shit. And,
I think there was a lot of useful information there. which is very important.
Yep. So I guess we'll talk in 2 weeks again.
Yeah, good stuff. Thank you.
Thank you so much.
Okay. Bye, guys.